We're all living through this massive AI revolution, right? It feels like it's all about the software. But what if I told you there's a secret, second revolution happening right now? One that's less about code and more about the fundamental physics of how computers talk to each other. We're talking about a leap from electricity to light.
And look, you see the results of this AI boom every single day. It's in those incredible images you can generate out of thin air, the code that practically writes itself, and, of course, the chats we have with these huge language models. The progress is just, it's right there in your face, and it feels like there's no limit.
But here's the thing. All of that amazing growth is creating a problem that no amount of clever software can fix. The very foundation of our data centers, the actual physical wires connecting all of this computing power, is starting to buckle under the pressure. There's a hidden bottleneck, and it's threatening to grind everything to a halt.
And that is the central question we are going to dig into today. What do you do when the supercomputers that are building our future get caught in a gigantic, planetary-scale traffic jam?
Okay, so let's break this down. Modern AI doesn't run on just one chip. No way. It's more like a giant superbrain built from thousands, sometimes tens of thousands of GPUs all working together. And for that brain to function, every single part needs to be talking to every other part, all the time, perfectly in sync. And that, as you can imagine, creates an absolutely insane amount of data traffic.
You don't have to take my word for it. NVIDIA's CEO Jensen Huang put it just perfectly. He said, "We are basically manufacturing supercomputers like chiclets." Think about that. The scale is just staggering. We're not just building a few of these things, we're churning them out. And all those little chiclets have to be wired together to act like one single powerful mind.
And that's where we meet the villain of our story. Good old copper wiring. I mean, for decades it's been the workhorse, the backbone of data centers. But for the kind of gigascale AI we're talking about now, it's officially obsolete. The electrical era is hitting a hard physical limit.
And here's why it's failing us. When you try to push more and more data through copper, the signal just gets weaker and weaker. That means you need power-hungry boosters to keep it going. All that power creates a ton of heat, which means you have to spend even more money just on cooling. It's also really susceptible to electrical noise, and, this is the big one, you literally run out of physical space to plug in all the connections you need.
This problem has a really cool name, the shoreline limitation. I want you to picture a computer chip's edge like it's the coastline of an island. You need to build more and more highways to get data on and off the island, but you've just run out of coast. You can't physically add any more connection pins to get the data moving fast enough with electricity. You've hit a wall.
So what's the alternative? Well, when you put copper side by side with optical fiber, the difference is, well, it's not even a contest. Look at this. Copper tops out around 40 gigabits per second. Fiber? It can hit 6.4 terabits. That's not just an improvement, it's a completely different universe of speed. Then you see it uses way less power and is totally immune to interference. The choice just becomes crystal clear. So the solution is to make a fundamental change in the physics we're using. We are literally replacing electrons moving through metal with photons, particles of light, zipping through impossibly thin strands of glass. This is the optical revolution. This is the hero of our story. Now, this didn't happen overnight. It's been a journey. At first, we had these optical modules you just plug into the front of a machine. Then things got a bit cozier, and the optical parts moved onto the same circuit board as the main chip. But the real game changer, the massive breakthrough, is something called co-packaged optics, or CPO. That's where the engine that turns electricity into light is fused directly with the computer chip itself. And the impact of doing this is just immense. By making the distance electricity has to travel before it becomes light incredibly short, CPO slashes energy consumption by over 50%. And that is a huge deal. It means less power gets wasted on just moving data around, freeing up all that precious energy for the actual number crunching, for the real computation that makes AI work.
Okay, so you're probably wondering, how in the world do they actually pull this off? It sounds like science fiction. Well, this incredible leap is really being driven by two key technological breakthroughs that let us route light around at the microscopic level of a computer chip. And to give you a sense of just how wild the scale of this is, listen to this little story from a company called Marvell. They were showing off a new piece of AI hardware and asked a bunch of engineers to guess how many optical fibers were packed inside. Most people guessed, around 250. The actual number? 1,152, all in one slim server tray.
And that is the magic of CPO. It enables this mind-boggling density of connections. We're not just swapping out one copper wire for one fiber optic cable anymore. We are building a massive parallel information superhighway that flows directly into and out of the very heart of the processor.
But just when you think it can't get any faster, it does. The next big innovation is changing the fiber optic cable itself. See, in traditional fiber, light has to travel through a solid glass core, which actually slows it down a little. The new hotness is hollow core fiber, where the light travels through a channel of air. The result? The light moves at pretty much the true universal speed of light.
This change reduces something called latency, basically the delay in data getting from point A to point B, by about 31%. Now that might not sound like a huge number, but in the world of AI, where GPUs have to sync up trillions of times a second, it's an eternity. It means faster training times and AI that feels way more responsive.
So, let's pull back for a second. What does all of this really mean for the future? This isn't just about making AI training a little bit faster. This foundational shift, from copper to light, is going to completely reshape how we design data centers and, honestly, the entire tech industry along with it.
What we're witnessing is the birth of what people are calling the AI factory. These new optical interconnects make it possible to link millions of GPUs together so they act like one single colossal computer. It's way more energy efficient, and it's also more reliable, which is critical when you have training jobs that can run for weeks on end. And this isn't some far-off dream. The biggest names in tech, like Meta, Oracle, and Microsoft, are already building their next-gen systems on this optical foundation.
And, as always, you can just follow the money. The market for silicon photonics, that's the core tech that makes CPO possible, is projected to just explode from about $1.6 billion in 2023 to over $11 billion by 2031. That's a massive economic bet that this optical future is the real deal.
So I want to leave you with one final, kind of mind-bending thought. The AI that has already changed our world so dramatically was built on the limitations of electricity. What new abilities, what new kinds of intelligence will emerge from an AI that can finally think and communicate at the true speed of light?